Let's set up a WEG CFW300 drive with 3 digital inputs to control 8 different reference frequencies. Maybe you have a drill press, and depending on the material that you're drilling or the bit style you're using, you want to be able to select with a switch which spindle speed you want without having to dial in the correct speed manually. Well, that's what this multi-speed option is for. Given 1 to 3 digital inputs, you can select up to 8 possible predetermined frequencies. And it's easy to do. But there are a couple things you need to be aware of when implementing multi-speed, so let's do a couple quick examples so you can see what to look out for. Before we get started though, let's reset the drive to factory default so we're all starting in the same place. I'll set this up using the free WEG WPS software because it's easier for you to follow along. My PC is connected to the drive via the optional USB module. Now you don't need the free software or the optional module. You can do all of this from the drive's built-in HMI keypad. I'll even give you a summary list of parameters at the end so you don't have to remember all of this. I've already created a configuration and a resource, and I'm connected to the drive. For this demo, we'll operate multi-speed in local mode, so I'll search for local, and we see that the local reference frequency source is set by parameter 221, and it defaults to being controlled by the HMI. So we'll change the local reference frequency to being controlled by the multi-speed function. Well, now we just need to assign digital inputs to control the multi-speed. This is where it gets a little tricky. This chart in section 723 of the user manual is your best friend because it tells you everything you need to know. These parameters hold the 8 possible reference frequencies that we'll be able to select from. If I search on multi, I see the default values are these, so I'll add those to the chart here as a reminder. Now these default values are for the 60 Hz factory reset we just did. They'll be different if you reset the drive to the 50 Hz factory default, so just be aware of that. The key thing to note here though is only these digital inputs can be used for bit 0. These digital inputs can only be used for bit 1, and these digital inputs can only be used for bit 2, the most significant bit. So for our first example, let's use these to control multi-speed. I'll search on DI and set DI1 to multi-speed, DI3 to multi-speed, and DI4 to multi-speed. Again, because they're all predefined, the drive already knows which one is going to control which bit. Well, that's it. Except it looks like we have a configuration error. What's going on? Well, remember, whenever you get a configuration error, go to parameter 47. It'll give you a pretty good idea what's going on. Looks like this is telling us that either parameter 224, that's the local run stop, or 227, the remote run stop, are trying to use digital inputs that we're using for multi-speed. If we search on local, well, it's not using any digital I/O except the multi-speed stuff we're using. That's okay. Let's go look at remote. Remote is expecting digital inputs to control the forward and reverse and the run stop. There's the issue. We're using DI1 for multi-speed, but remote mode is expecting it for run stop. So let's make the remote run stop controlled by the HMI for this demo. Wait for the change to take effect. That can take several seconds depending on how busy the drive is. There we go. The screen just updated. And look, the drive no longer has a configuration error. Perfect. So if we turn all 3 bits off and hit run, the drive runs at this speed. If we enable bit 0, then the drive runs at this speed. Turn that off and enable bit 1, we get this speed. Enable bits 0 and 1, we get this speed, etc. We can now select one of 8 preset frequencies. Cool. And by the way, don't forget, you can monitor the digital I/O either through this parameter, that number appears in hex, or via one of the wizards. Now we used the default speeds in this demo, which if I search on multi, we can see those here. But you can change these to any value you want, and the minus sign indicates direction. Let's change the second value to a -3 Hz. Wait for the screen to update. Again, that can take several seconds. There it is. Now when I flip bit 0, the motor runs in the opposite direction. Perfect. The WEG drives have a secondary multi-speed feature. We set our digital I/Os to multi-speed. If instead we had set them to this second ramp multi-speed, then multi-speed would use the first set of ramp parameters to control the drive during startup and shutdown, and the second set of ramp parameters to control how the drive changes between frequencies while the drive's running. It's just one more way you can refine how multi-speed operates. Now be careful. When using this feature, don't set parameter 105 to a 1. That'll force the second set of ramp rates at all times, which isn't what we want here. Now I used these discrete switches in this demo so you could see which bit I was controlling. Would you normally do it like this in your setup? Probably not. Most of the time, you would use a PLC or some other kind of controller to control those bits, perhaps even with an HMI. Here's a summary of the parameters we used in this video. And really, all we did was tell local mode its frequency will be controlled by multi-speed. We set up the 8 preset frequencies, and we configured the 3 digital inputs to configure which of those frequencies we want to use. Click here to learn more about the WEG CFW300 variable frequency drive. Click here to learn about Automation Direct's free award-winning support options, and click here to subscribe to our YouTube channel so you'll be notified when we publish new videos.